Hi AP Stats, this is Mrs. Cowles, and today we're going to take a look at modeling data with quadratic functions. Our objective today is to identify and write quadratic functions. So you want to cross out that word graph and change it to write. So that's our goal today. So we've been working with a quadratic function. We know that we have a quadratic function when our highest degree is to the second power. And in standard form, our quadratic function can be written as f of x equals ax squared plus bx plus c, where a does not equal 0. And again, we always like to have our a term be positive when we write this out. So we are going to highlight that just so we can see that is our standard form. Okay, so let's take a look at this first example here. It says, determine whether each function is linear or quadratic. Identify the quadratic, linear, and constant terms. Well, before we can identify it, it's important that we simplify each function. So when we take a look here, I have f of x equals x squared plus 5x minus x squared plus 12. Now, I look here and I have nothing outside the parentheses, so I know that means in my head I can just go ahead and drop the parentheses since there's nothing to distribute through. I'm going to show that on the notes where I actually rewrite that out. Now that the parentheses are gone, we can go ahead and we can combine like terms. We see our quadratic terms, we have a 1x squared and a negative 1x squared. We can cross those out. So we are left with f of x is equal to 5x plus 12. Now as we take a look at this, our highest degree is 1. This is a linear function. So we classified it as linear, and now we're going to identify the terms. Our linear term, which I'm going to call LT, is equal to 5x, because it's the term with a degree of 1. And then our last term is 12. That is our constant term, which I'm going to call C for constant. Constant has a degree of 0, because there's no variable. All right, let's continue on and try the next one. So again, we want to simplify it in order to identify if it is quadratic or linear. Now, we should be able to take a look at this, and we'll talk about this in just a second, but we should identify that this is going to be a quadratic because we can go ahead and we see we're taking the product of two linear binomials, and we have been seeing that the product of two linear binomials becomes a quadratic trinomial. Now, if I also take a look at each of my factors, I can count the number of x's. I have an x here, a linear term, and another x, 3x here, a linear term. So when I count the number of x's, I know that in my final product, I'm going to end up with x squared. So therefore, it should be a quadratic. Okay, so we should be able to tell in factor form by counting the x's that we have a quadratic, but let's go through and multiply it out so then we can classify each term. So we are going to use double distributive property. We'll distribute the x through first. We're going to have 3x squared minus x, and then we'll distribute the negative 5 through, so that's minus 15x and a plus 5. So we'll continue to solve that, or simplify that I should say, and we're going to end up with 3x squared minus 16x and a plus 5. So we verified what we said, that it is going to be a quadratic because our highest degree is 2, and now we're going to identify the quadratic term. The quadratic term has the x squared, so that is 3x squared. The linear term is going to be negative 16x, and our constant term is going to be 5. Now, we've learned from Algebra 1 that when we graph a quadratic, it's going to have a U-shaped curve, and we call that U-shaped curve a parabola. When we graph a quadratic function, we know it's going to be a curve that's either going to open up or it's going to be a curve, that U-shaped curve is going to open down. Now, we have symmetry with that curve, and we can identify our axis of symmetry. It's a line that divides the parabola into two equal parts. So when we go ahead and we sketch in a parabola here, we can draw our axis of symmetry right through that. And the axis of symmetry will actually cut right through our vertex, and we're going to call our vertex H, K. Okay, so if I was to identify my axis of symmetry, it's going to have an equation, because it's a vertical line, x equals h, where h is the x coordinate of our vertex. So here I'm going to call this A, OS for axis of symmetry, it's going to have the line x equals, because it's a vertical line, all the x coordinates are the same, and it's going to equal the x coordinate of our vertex. Okay, the same thing would occur if we had the parabola opening down as well. We find our vertex, and the axis of symmetry would go through the vertex because it's going to cut the parabola in half. We'll call our vertex h comma k, and it's going to have the equation x equals whatever your x coordinate is, and in this case it's x equals h. Okay, so again, x equals h is the equation because it's a vertical line, and h is the x coordinate of your vertex. So speaking of vertex, the vertex is the turning point of our parabola. It's either going to be a minimum or it's going to be a maximum, the highest point or the lowest point. We can identify that minimum or the maximum by looking at the y coordinate of the vertex. The y coordinate will give you the minimum value or the maximum height for your function. So again, you can just do a quick little sketch. Here is your vertex, and we're going to have h comma k, and we see this one's opening up, so it has a minimum, and the minimum height will occur at the value of k, your y coordinate. If it opens down, the vertex will be at a maximum, and we can always identify the maximum by looking at the y coordinate. In this case, the maximum would be at k. All right, let's continue on and take a look at the rest of the examples. Okay, for example 2, identify the vertex, the axis of symmetry, and the points and the corresponding points. And the corresponding points are going to be called P prime and Q prime. That should be a single, it's like a apostrophe up there, we call that prime. So P prime and Q prime. We're going to look for the corresponding points to P and Q. Okay, so if we take a look, we can identify our vertex very clearly. We can mark it on our graph, and we see that the ordered pair would be 1, -1. Now our axis of symmetry, I'm going to go ahead and draw that in. I can see our axis of symmetry goes right through our vertex, and our axis of symmetry is a vertical line, and it's going to be equal to x equals 1. It goes through our vertex, our x coordinate at 1. All the x coordinates on that line are equal to 1. So our axis of symmetry, or AOS, has the equation x equals 1. Now, if we want to find P prime, I find the point P, and all we do is we reflect it over our axis of symmetry. So I'm 2 to the left, I'll reflect it over here, 2 to the right. I'm going to call that P prime. And if we look at that ordered pair, we can see that it's going to be at 3, 3. So I'll mark that in my graph. P prime is 3, 3. And then we're also going to do the same thing and find the reflection of Q prime. So, or of Q. So we have right here, we have 2 zeros. So we're going to reflect that over and label Q prime on our graph. And Q prime will have the ordered pair. If we take a look, that's actually going to be at 0, 0. So I'll even label that because it's at our vertex. So Q prime is equal to 0, 0. Now, if I give you 3 values, you should be able to find a quadratic function that you should be able to find a quadratic function to model these values. Okay, so to do that today, we're just going to go ahead and learn how to use our graphing calculator. So we're going to use our graphing calculator with these 3 points. So what we're going to do is we're going to take our graphing calculator and we're going to enter the points. To do this, you're going to type the stat key and you're going to hit enter. So I'm going to put my calculator down here, and we all should now by know where our stat key is. Here's our stat key. You're going to type that and you're going to hit enter. And if there's anything in your list, go up to the top and hit clear enter. So I'm going to go through and clear out my list. And in L1, you're going to type the x coordinates. So in my list 1, I'm going to type 1, 2, and 3. Then the directions say in L2, you're going to type your y coordinate. So we're going to type 0, -3, and -10. So we can see we now have our ordered pairs in the table. Now we're going to go back and we're going to type the stat key again, and we're going to scroll over to calculate. So go back and hit your stat key, and you're going to scroll over to where it says calculate. And then we want to do a quadratic regression. So in your calculator, that's called Quad REG, and you're going to scroll down to number 5, or you can just type the number 5, which is what I'm going to do. So quadratic regression, and then hit enter. Now you should select the list that you are doing the quadratic regression with, depending if you did, especially if you didn't type it in L1 and L2. So I'm going to type L1, comma, L2, because those are the two lists that I typed them in. And then you should be able to hit enter, and it will do a quadratic regression. And you can see on here, we have y equals ax squared plus bx plus c, and it tells our a value will be -2, our b value will be 3, and our c value will be -1. So we can go through now, and we can write our function. And I'm even going to put f of x, because we've been learning that our outputs are called f of x. And we're going to have -2x squared plus 3x minus 1. And that is the quadratic model that where if I was to plug in the inputs given here, will give me the corresponding outputs. All right, so let's take a look at the last example. The table below shows the height of a column of water as it drains from its container. Write a quadratic function to model the data. So our goal is to write the quadratic function. So we're going to use our calculator to do this once again. And this will be our input, our x, the elapsed time. This will be our f of x, and we're going to put this in L1 and L2. Now again, you can use L3, L4, whatever list you put it in. Just make sure you select that when you are doing your quadratic regression. So to get there, we go back to Stat, Edit, and to clear your list, you go up to the top, hit Clear, Enter. Don't hit Delete. If you hit Delete, you'll delete the whole list, and the L1, L2 will disappear. All right, so go ahead in L1, put in the time in seconds, and then you're going to go to L2, and you're going to put in the water levels. So go ahead and type that in. Okay, once you have your list typed in, you want to start to learn the steps. You're going to hit the Stat key once again, and we're going to go over to Calculate, and we want to do a quadratic regression. So that is number 5. Now again, select your list. I did L1, comma, L2, and then we hit Enter. And from here, I can determine my function. So we're going to go ahead and we're going to write that out. We're going to have f of x is equal to, now my a term, I'll go several decimal places out. I'll put 0.00917 approximately, x squared. And then we're going to have minus 1036 x, and my c value, I'll put plus 120.3. And there is the quadratic model to represent the water level given on an elapsed time. So now we go down to the last step. It says use the model to estimate the water level at 35 seconds. So if my time is 35 seconds, I know that 35 is going to fall somewhere in here on my table, 35 seconds. So I know my answer should be somewhere between 66 and 50. So we're going to plug in 35 seconds for our x value, and we're going to do f of 35 is equal to 0.00917 times 35 squared minus 2.1036 times 35 plus 120.3. So you're just going to take your calculator and you're going to plug that in, and let's see what you come up with. 0.00917, and we're going to have 35 squared minus 2.1036 times 35 plus 120.3, and I come up with 57.9, almost 58 millimeters. And again, if we take a look, we made a prediction that between 30 and 40 seconds, it should be 66 and 50. So we know we did our answer correctly. All right, so our output at 35 is approximately 58 8 millimeters. And there you go, Algebra 2. That is modeling data with quadratic functions. Have a great night.